Taiping Airlines Math Industry here, and today we're gonna look at two-side variables, but with no numbers in them. So, what do you notice and what do you wonder about this equation? Well, what I usually wonder is why are there no numbers in this equation? And what I'm wondering is how can we do this? Well, when you first come up to see this problem, you might be thinking, oh, this is too hard, oh, I can't do it. Or maybe some people may be thinking like this. Actually, this is actually easier than you think. These type of problems are easier than the ones with numbers in them. Like these kind of problems, like with the numbers inserted into them, you actually have to do a lot of steps and a lot of math to figure out what x is. But in that case, there will be a lot of steps, but there's not really much numbering in them. So let's see how we can get x alone from this equation. So we gotta do this negative e and turn it into a positive e. This type of problem applies to the same problem like these right here. So they're the same steps, but the only difference is that there are no numbers in them. They're only variables. We did that negative e turn out to a positive e. Since we don't know what p and since we don't know what e is, we just write p plus e because we don't know what they represent. They could be cars, trains, planes, channels, who knows? So now we have vx, so v times x equals p plus e. We're going to have to divide both sides v because they cancel out and they get rid of each other in a battle because we want to get x alone. So you do p plus e and divide that by v. Now our final answer is x equal p plus e, divide that by v. That is actually easier because there's not really numbers in them and there's nothing to represent x and there's nothing to represent the others. So this is the simplest form as we can go. We can't go any further. So x equals p plus e, divide that by v. Too bad we can't get this simpler. we can't simplify it more. This is as far as we can go. Let's try another problem. So yes, we do see a 3x right here. Our agenda is to get x alone. So since we know it's x that's the one that has to be alone, we can circle it or we can mark it in a different color. So we're gonna have to do that minus ay, and we're gonna have to plus that ay. So we can distribute, well not distribute, you can move that right here over here. So m plus ay. And we have that 3x here. So 3x equals m plus ay. That's supposed to be an a. Then since we want to get x alone, we divide both sides by 3 as the same steps in the ones with the other numbers. So since these cancel out, x equals m plus ay, multiply that by y, and divide that by 3. If we see a variable like a and b, and they're meshed up together, there's an invisible multiplication sign, which is a dot, saying a times b is the same thing as ab. So this is the simplest form we can get for this problem. Having one with numbers and having one with variables, they have the same steps, but the answers are going to be different because with this one, the answer is going to be x equals a number such as 10. But instead, this is going to be a variable, x equals a bunch of variables and divide that by something. So with this one, you're not going to get to an answer x equals a number. You're not going to really get that because you don't know what these variables are. How does this apply to the real world? So, many mathematicians use this method for finding the steps of a formula. In case you're not given the whole formula, you can use this method to find out what the missing information is. I'll put up a sample formula for you. Potential energy equals mass times gravity times height. We have that formula here. This is the information, the whole information we need. But what happens if you say, what does gravity equal? Well, many engineers that use this method will say we're not given the whole formula and the whole information of what potential energy is. We'll have to use these limited variables and see what one of them is or what the missing one is. So gravity equals potential energy, divide that by mass times height. Why? If you do this times that, that would be potential energy. And do the potential energy, divide that by this, multiplied by that, you'll get gravity. Or you'll get a number that represents gravity. Here's another example. No, the area equals base times height. That's the area for a square and a rectangle, but there's a problem. They only gave us what the base is. So, since area equals base times height, we should say that the area divide that by the height equals the base. So you're already given the area, and they already give you the height, but you do the area, divide that by the height, so you know what the base is. So basically, mathematicians use this method to find the missing information. So what is potential energy? Potential energy is when an object wants or must overcome gravity. So it's going in an upward position, and it tries to overcome gravity, such as the object overcomes gravity by going up. So, this baseball is overcoming gravity. So here's another example of potential energy. Rockets. So this is a dance that happened before the rocket launches. So
situation sorted.
Yep.
Guys, the rocket's launching. We gotta do something before they get into orbit.
We need to come up with a plan, quick.
Rockets must overcome gravity, so they have a lot of potential energy, because they are going up, and the gravity is pushing you down.
Okay guys, I have the most awesome plan.
I'm gonna crash headfirst into the cafeteria window.
What do you mean? You're gonna jump out and smash it with your head?
No, it's my helicopter. What do you guys think? I'm ready to...
Hold on, I don't really understand.
What's not to understand? It's simple. I fly the helicopter into the window.
But how does that help?
I don't really think you get it. Henry, you get it, right?
I guess I'm outvoted then.
I think it's a little bit out of range now.
Thank you for watching this video. Like and subscribe to Taoping Airlines Math Industry. Thank you.